wear resistance, throughput rates, and grinding properties determine the operating efficiency of rolls. The end product quality that the market demands can only be achieved with consistent grinding, flaking, dispersion, and homogenizing characteristics. A high return on investment depends on a high material throughput. On the other hand, high throughputs with a consistent material quality call for a uniform low temperature across the entire roll surface. Bühler meets these rigorous demands with its centrifugally cast compound rolls. They feature a hard, wear-resistant outer shell and a soft, tough inner base. The Bühler process guarantees a consistent hardness along the entire length and throughout the depth of the outer shell. In the centrifugal casting process, the hard iron alloy is cast into a gravity die rotating at high speed. In a second operation, the gray iron is poured into the die. In roll manufacture, Bühler cooperates closely with its competent partner, Guntermann & Pipers, in Siegen, Germany. This company applies advanced foundry equipment. Its in-house laboratory assures quality by material analyses, research, and development. The state-of-the-art manufacture of these centrifugally cast compound rolls is based on the vast experience of Guntermann and Pipers and on Bühler's own expertise accumulated in the course of more than 40 years. Advanced melting processors monitor the furnace continuously. All relevant data is recorded. Numerous on-site samplings and analyses ensure a consistently high casting quality. The composition of the molten metal is determined by casting a specimen and analyzing it in a spectrometer. Final adjustments are now made. Before the metal is tapped, the correct temperature is set. An accurately metered amount of molten metal is tapped and poured by the Bühler centrifugal casting system through a channel into the high-speed gravity die. The high centrifugal force of this horizontal die generates a high material compaction and homogeneity. As soon as the compounding temperature of the still viscous hard shell has been achieved, the gray iron is poured into the die. The die continues to rotate until the metal has solidified to the necessary extent. It is then released by the centrifugal casting machine. The fresh roll is ejected from the die. Before its quality is inspected, the raw casting is rough-turned to the correct dimensions and subjected to an on-site Brinell hardness test. Meeting the high customer requirements is the prime objective. Therefore, a specialist examines each roll for inclusions and casting flaws. Following rough machining and inspection, the rolls are shipped for further processing to Bühler Limited in Uzwil. The shoulders and the inside of the rough machined castings are turned to the final size. Automatic state-of-the-art CNC lathes complete the trimming of the roll journals. The raw steel components, pre-forged in a single piece, undergo final drop forging. This gives them enormous strength. All turned parts are inspected for dimensional accuracy. Extremely narrow tolerances must be observed. In the case of small roll diameters, applied mainly in grain milling, the journals are pressed in. The journals on the rolls are then polished, with the dimensional accuracy being continuously checked. For large roll diameters, journal fastening holes are drilled into the roll shoulders. The journal flanges are also provided with the appropriate bores and are then fastened with the correct torque to the rolls. All rolls are polished to an accuracy of 0.5 of a millimeter. This process, too, is subjected to permanent monitoring. Smooth rolls are provided with a precisely pre-calculated crowning, matched to the particular application. Break rolls receive corrugations, according to their particular function in the mill. The shells of large rolls, mainly those used for paint and printing ink production, are provided with longitudinal bores for cooling. Dynamic high-speed balancing of each individual roll prevents vibration later on during operation. The extensive quality inspections performed include checking and filming of the crowning. The results are archived along with the roll identification number. To assure and continuously improve roll quality, Bühler has since early on operated its own development laboratory boasting state-of-the-art equipment. Here, new material compositions are developed and tested. Customers' requirements, which vary widely according to the particular industry, are covered by a broad range of rolls with different structures and hardnesses. Bühler can draw on a vast wealth of experience in the development, manufacture, and application of rolls and roller mills. The first roller mill equipped with Bühler rolls left the factory in Uzwil in 1876. Since then, no less than 500,000 rolls have been delivered to customers, of which 150,000 were centrifugally cast compound rolls. Innumerable customers take advantage of our efficient after-sales service. Roll wear and contamination reduce throughput and affect the end product fineness. Roll servicing at Bühler Uzwil headquarters or one of its affiliates worldwide starts with roll removal. The rolls are machined inside and outside with the same precision as new rolls. The crowning is matched to the new shell thickness. Professional roll overhauls guarantee a long roll service life and consistent roller mill capacity. This after-sales service contributes to the business success of our customers. Bühler rolls are production tools of unsurpassed quality. Thanks to their high wear resistance as a result of their uniform deep surface hardness, their homogeneous, precisely defined structure, and their consistent casting properties, their stability resulting from high material compaction, their high throughput capacities, and their high-precision, true-running characteristics assuring accurate grinding gap control. Bühler rolls thereby ensure high capacities and reliability. Bühler rolls, the guarantee for the top quality of your products and for your market success.